All right, hello everybody. We're going to go ahead and get started on our last topic for Unit 1, which is going to be on aquatic biomes. So earlier this unit, we talked about terrestrial biomes, things like grasslands and forests and deserts, and how temperature and precipitation was largely the defining factors between those. For aquatic biomes, we're going to have a couple of different abiotic factors, which kind of determine the organisms that live there and how they've adapted to it. So the abiotic factors that we're going to be talking about for aquatic biomes include temperature. So what is the temperature of the aquatic biome? Is it colder, hotter, more exposure to water, heavily shaded? All of these are going to play a role in the amount of photosynthesis, but also a lot of the organisms that live in these aquatic biomes are ectotherms, which means they regulate their body temperature externally, which means it's harder for them to survive in extreme temperatures. Plus, we'll see later that temperature does affect dissolved oxygen levels. So, organisms in aquatic biomes need to breathe oxygen, just like organisms on terrestrial biomes as well. And so, temperature is going to play a role in the amount of dissolved oxygen available there as well. Next is light. So, how much light do you have available in your aquatic ecosystem? This is going to be primarily used for photosynthesis, also for predator prey relationships. Organisms need to be able to see for the most part when they're hunting, unless they're specifically adapted otherwise. Next, we're going to have dissolved oxygen. Dissolved oxygen is the amount of oxygen that is in the water that organisms need for cellular respiration. This is largely determined by a few things. The biggest one is going to be temperature and then the biological oxygen demand. So, how much oxygen is being used by decomposers in the area. And we'll talk more about that in Unit 5. Next is going to be nutrients. So, how much organic matter do you have available? Things like nitrogen and phosphorus, which is required for organisms. And then finally, depth. So, how deep is the biome? This is going to affect things like how much light you get, how much food availability will be there, and things like that. Okay? One that we have over here, I didn't include in this image, is suspended matter. So, how much eroded soil do you have in your water? This mostly works to deflect light and interrupt predator prey interactions. Plus, it can interrupt the natural development of organisms as their shells are not watertight, which means water can flow in and out. So this suspended matter, also known as turbidity, can impact a couple things as it applies to aquatic biomes. All right, when it comes to biomes or aquatic biomes, we're going to divide them into two categories. We're going to have freshwater, which are bodies of water with no significant amount of salt in them. And then we're going to have marine biomes, which are biomes that have significant amounts of salt in them. So when it comes to freshwater biomes, we have three main categories. We have rivers and streams. These are fast-moving currents. Rivers and streams don't really have a defined size to determine between the two, but typically rivers tend to be larger while streams tend to be smaller. Humans do impact rivers and streams mostly through sedimentation and pollution. So if we have deforestation along rivers and streams, or we have a major city along rivers and streams, which we tend to have, pollution and sediment runoff can be an issue. Next, we have ponds and lakes. Uh, Ponds and lakes are freshwater as well, except they are just sitting bodies of water. Pond, like streams, have lower volume, while lakes have higher volume. Humans impact these through things like nutrient pollution, regular pollution, and sedimentation. We'll talk about all of these human impacts a lot more in Unit 7 and 8. And then you have wetlands. These are areas that are wet for part of the year. These include places like marshes, swamps, and bogs. So think of like the southern United States, like Mississippi and Alabama. Depending on the type of vegetation that is there, that is what dictates what type of wetland it is. So marshes are non-woody vegetation. So think of like grasses and stuff like that. While swamps are woody vegetation. So things like trees. Michigan, especially central Michigan, has a lot of swamps that you can see as well. Okay. Next, we have marine biomes. These are aquatic biomes that have significant amount of salt in them. And I'm going to play this video here on the side. So hopefully it'll show up. But the first one we're going to talk about is intertidal zones. These are areas where tides of water move in and out throughout the day due to interactions between the Earth, the Moon, and the Sun. So here we can see it's early in the morning. The tide is low, so the water depth is really low. But as the day advances, that tide is going to come back in, and the water is going to rise with it. So these areas are mostly defined by their wide range of abiotic conditions because the amount of light, depth, temperature, all of those different factors we talked about in the first slide are going to rapidly change throughout the day as that water goes up and down. Okay? Coral reefs, these are shallow marine biomes. They are primarily propped up by a type of symbiotic relationship between corals and zooxanthellae, which is a type of algae that lives in the area. The big thing about coral reefs is they are the highest level of biodiversity in these shallow marine ecosystems. And humans do largely impact this and intertidal zones for a lot of the same reasons, including things like fishing and boating practices. But again, we'll talk these in a lot more detail when we get to Unit 7 and 8. The next one we have is open ocean. In open ocean, this is exactly what it sounds like. Once you get past this continental shelf, you start getting into the part of the ocean where you have depths of several kilometers to hundreds of kilometers. And this is just deep ocean that extends from there. The most important zone to know about the open ocean is the abyssal zone. This is the bottom layer of the ocean down here. These tend to have the highest nutrients because as organisms die, they'll then sink and decompose. So most of the nutrients are going to be found in that lower abyssal zone. The last ones we need to talk about are, for marine biomes, are estuaries. Estuaries are areas where freshwater rivers meet the sea. So here you can see the river coming from the inland, and then it deposits out here. These tend to be very high in nutrients because all of the erosion that occurred along the river and stream tends to get dumped out here. We also tend to have a lot of sediment pollution here because of all the erosion that occurred here as well. The biodiversity tends to be very, very high due to the amount of nutrients as well. It's a very biodiverse area, a very healthy food web, and a lot of productivities to support all those organisms as well. And then we have two types of wetlands. We have marshes and swamps, except when we have a swamp in a marine area, we call it a mangrove. But they're going to be very similar to the ones we talked about in the last one. Salt marshes are non-woody vegetation, think of like grass, things like tall grasses and cattails, while swamps are going to be wood-based. Both of these provide a lot of ecosystem services that we'll talk about in Unit 2. And the biggest impact for all wetlands is the idea that humans overexploit them and destroy them in order to create urban areas in that area because it is a highly desirable area to live on the coast. All right, so here's our FRQ for today. Make sure you read through the scenario there and answer the 3 questions, and then we will talk about them on Monday.